Okay, did this work? Let's see if this worked. Oh, I'm hearing an echo. Okay, looks like we are live. Audio? Live. Audio. Cool. Audio? Cool. Audio? Cool. Okay, now I just have to send a link around. Let me do that. Okay. All right, let me ping my folks. Well, how do I want to say this? How do I want to say this? Walking through ARC-AGI-3 games to analyze how humans approach these kinds of reasoning tasks. This feels so cold and rigid. And also doesn't explain what ARC-AGI is. Current benchmark for reasoning tasks that modern AIs are poor at. We are going to walk through ARC-AGI-3 Yeah, that's close enough. Cool. All right, and now if I go back here, and I go back here. Oh, I don't have chat anywhere. How do I want to handle that? This is my chat thing right here. Oh, it's not even signed in. Okay, do I... Here. Let me pull this tab out. This is super ghetto. Can I pop this out? Pop out chat. Oh, great. Wonderful. Then I'll put this back here. Put this back here. Okay. And then if I do this, this, let's minimize a bunch of stuff that we don't need. Okay. Okay, that works. I think that works. Now I have some OBS control as well. Not really, actually, but whatever. Okay, this works. All right, cool. So we're gonna play through this. So for those of you who haven't seen ARC-AGI-3 before, the way it works is that it's basically a bunch of interactive games that they're puzzle games. They're puzzle video games that are designed to be fairly intuitive to humans, but challenging for current AI agents. And so that makes them very interesting in the quest for AGI. So we are going to play through some of these games and try to get a sense of how humans approach these problems. And what I want to do here, like, I'm not just trying to beat the game, right? Like that's incredibly boring. That's not what I'm trying to do. I'm not trying to beat the game. What I'm trying to do is painstakingly, belaboringly go step by step through every little bit of my cognition process that I can be aware of and document that. And hopefully in the future I can come back to this VOD and review it, maybe get some ideas for how to structure models going forward, or maybe I can capture this transcript, feed it to an LLM, have it analyze it. Various things are possible. But yeah, we're gonna work on, we're gonna go through some of these games and talk through this stuff. Play humans. Okay, so there's 25 public games. There's, I believe, 55 fully private games, and then there's some number of semi-private. What semi-private means is that they're not published on the website anywhere, but they have been shared with companies that host LMs. For example, like OpenAI is my understanding, like OpenAI, Anthropic, Google, etc. have had access to the semi-private set. So there is some risk that training data for LLMs has been poisoned with that set. So I'm not really that concerned with that set. Right now what I care about is the 25 fully public ones and the 55 fully private ones, right? The deadline for this competition is November 2nd, so that's a few months from now. And so far, performance isn't super good. Definitely not from the LLMs. So for our ARC-AGI competition, there is a computation limit. I forget what it is exactly, but like you can't just use a gazillion GPUs. They have some like clear limitations on how much compute you can use. Okay, so there's 25 games, and you can see at the top right how many levels each has. 7, 8, 6, that sort of thing. We're gonna go through these. I'm gonna go through. Yeah, we can go through the first one first. The first one's a little bit boring, I think, for a lot of people because they've seen this one already, because it's the first one. But I kind of want to go through all of them. I think it's useful. Like, there's only 25, right? I'm not going to go through all 25 today, but I think it would be useful probably to go through all of them. Because I think the idea is that every game is testing some unique aspect of reasoning or a combination of reasoning features or something. There's like some unique twist that each game presumably captures, and presumably the fully private games have their own unique twists too, but it'd just be good to get a sense for what they are in the public games, to get ideas, get inspiration, get understanding. Is there a way I can make this bigger? Very cool. Very cool. Okay. What the AI sees is a 64 by 64 pixel image, basically. And each pixel is one of 16 colors. There's a set 16 color palette. It's a 64 by 64 image with these 16 colors. And we're given what buttons we have available, but not what they do. Okay, and the buttons are, roughly speaking, up, left, down, right, although it's not always as obvious as this, is my understanding. There is spacebar, which is for interacting with things. There is undo, which is apparently only a thing in training, not in evaluation. And then there's mouse click. And mouse click is interesting because all of these other buttons are just standalone buttons, but mouse click, you click anywhere on the 64 by 64 image. So this mouse click suddenly gives you 4,000 more actions if a game enables mouse click. This one doesn't. As you can see, these three are grayed out. Different games have different subsets of these enabled. Some games have all of them enabled. The vast majority of them have mouse click enabled, so the large action space is important to consider. But yeah, these don't give the AI any additional rules. All the AI sees is what we're seeing, basically. Maybe even slightly less, because we see this up, left, down, right connotation, and I don't think the AI sees that. I think the AI sees action 0, action 1, action 2, action 3, and they might be in a different order. That's my vague understanding. I could be wrong about that. All right, so when I first look at the screen, so I've already done some levels of the first game specifically, and I've also tried the first levels of a couple other games, and so I've sort of spoiled myself a bit, right? But I'm gonna try my best to like approach this from the perspective of, oh, okay, I'm looking at this fresh for the first time. How am I analyzing this? And I'm kind of like going back to like how I remember doing it the first time and going at it that way, right? I think I did the first 2 levels of this. I think I might have seen my friend do a 3rd level. Okay, so I see the screen. The first thing is really just, I see a bunch of components, right? I see a bunch of standalone objects. I'm not really seeing 4,000 different pixels, right? I'm seeing a bunch of objects. So I see this thing in the lower left, which might be 2 objects. It's a weird looking thing, right? I see this thing up here, and I see that these things have a similar shape. I see that these things have a rotational symmetry between them, or a rotational, a rotation between them, right? Rotational difference. I see this plus thing. I don't know what it is. I see this blue-orange thing. I don't know what it is. There's some kind of HUD. I can tell that it's a HUD, but besides for that, I don't know what it is. And then this looks like walls and floor to me. That's what this looks like. And then we have these arrow buttons. Because we have 4 arrows, that tells me that like we have a character that we're moving around this floor. That's going to be either this blue-orange thing or this plus. It seems more likely to be the blue-orange thing because vibes, I guess. So I think that there are certain things within ARC-AGI where certain patterns will seem obvious as a human just because we're human, and that kind of common sense, I think, should probably be distilled from an LLM, I'm guessing, because LLMs probably just have the most consolidation of raw data about this kind of stuff. Which means we might use an LLM as like kind of a brain in some modules of the system, but there's also going to be some kind of reasoning harness around it. So an example is like if I click something and it changes color, I know I've selected the thing, right? That's just like something I kind of like know through experience. As opposed to knowing that I've modified the thing or something, right? I mean, it can change depending on the game, but I have certain priors based on experience. Or like if I see something red, I might be more likely to be like, that's dangerous, right? And I think those kinds of intuitions are baked into ARC-AGI, because the game is intended for it to be intuitive for humans. Anyway, my vibe is that the blue-orange thing is the player character, and that there is a player character, and these 4 buttons control WASD for the player character. Let's find out. And then what else do I see before I find out? I see that this is plus thing. That's interesting. And I see that there's this object that looks the same as this object. That's interesting. And the fact that they're different is also interesting. Because they're different, it makes me think that I should not go to this one first. Therefore, I should go to this plus first, even though I don't know what it is. Or perhaps because I don't know what it is. So I'm going to go to the plus first. This seems to be the shortest path, left and up, so I'm going to go left and up, and then we'll see what happens. Okay, so I clicked left. In one turn, we've pretty much confirmed that the left arrow key does in fact go left, which means that 90% chance the other 3 arrow keys do what you think they do, right? But we'll find out. So what we have going on here is that we have some kind of model that we're continually learning. I guess that's the buzzword now, but we're iteratively like updating based on new information, and we have things that we're certain about and things that we're uncertain about. So also when I clicked left, this yellow thing dropped 1 pixel, which tells me that probably every time I take a step, probably in any of the 4 directions, I lose one of these things, which means something bad happens when I run out. Probably game over when I run out is what I'm guessing, which means that this yellow bar probably means number of turns left in the game, or number of steps I have left in the game. I still don't know what these red things are. Maybe they're lives. Maybe they're lives. just through common sense experience, I guess. So now we're going to keep going towards it. Confirms the theory, confirms the theory. We come up with hypotheses, and then as we get more data, we validate the hypotheses or prune the hypotheses. Okay, now we're going to go up. That's going to validate the other arrow keys, or at least one arrow key. Yep, that validates one other arrow key and makes it like 99% likely the other two arrow keys do what we think they do, and that they all make this thing drop. I'm going through this very laboriously, like on purpose, right? I want to capture every little bit of information that might seem completely obvious and trivial to us, because those are possibly where the secrets of a new architecture lie, in my opinion. So I'm going to go up, and all right, I'm going to try touching this thing. Whoa, this thing rotated and flashed. The flash is interesting. I don't know if the animation goes through to the AI, because I think the AI just sees one frame at a time. So I don't know how that works on the AI side. But anyway, we see that this thing now matches this thing. Because they match, I'm going to go to it. Okay, right key works the way we think it does. And we never tested the down key. Okay, and that looks like we made it, and the yellow thing filled back up. Cool. Once again, we have this bluish blob and this bluish blob and their rotations of each other. We have some new object. We have some new yellow object. So I scanned the whole thing for objects and did object recognition on the 64 by 64 square. Mostly identified the same kinds of objects, but now there's this new yellow thing, and I don't know what this yellow thing does. But yellow is the same color as this yellow bar, and that is interesting. There might be a relationship there. We already know that we have to go to the plus to make this thing rotate, and we need to then go here to complete the level, just generalizing from the previous game. So in general, how do I want to say this? ARC-AGI is fundamentally trying to capture a certain notion of Occam's razor that humans know to be true intuitively. Right? Occam's razor is the idea that the simplest explanation is the best. Unfortunately, Occam didn't really define simple because you can't, right? Simple is kind of a vibes-based thing. Like, you can have some heuristics, right? Like, let's say I want to model this game as a piece of code. Maybe I can say, okay, we're going to find the shortest length piece of code. Or maybe we're going to find the code that has the shortest length branch conditions, or something like that, right? Like, we could use these heuristics. It's unclear how close they get to our real notion of what is simple and what is intuitive, right? You could define simple. Go ahead. Also, it's good to see you. There are certain situations where I think you could say one thing is simpler than another based on, like, you know, this model has more degrees of freedom than another model, and is strictly more complicated. In certain one-to-one comparisons, I think you can, like, say one is simpler than another, but in general case, you can't. I don't think that even in general you can say that, like, all models with 2 degrees of freedom are more complex than all models with 1 degree of freedom. Like, that doesn't match, like, how humans fit curves to reality, I think. Okay, so anyway, I'm gonna go to the plus. It seems intuitive. One thing I'm kind of intuitively seeing as I go through this is that I'm really running out of time as I get to this plus. And I'm not going to be able to make it back there. Because this thing is the same color, I'm going to hope that this thing gives me some amount of time back, because I don't see how else this is solvable. Ooh, and we need to rotate it again. Let's go ahead and pick this up, and it fully brings our meter back. Wonderful. And so we've learned that about yellows, and we're going to assume that this yellow does the same thing, because that is... So see, this is like one notion of simple, right? designing when things generalize and when they don't. You can say some things feel simple, but it's hard to be rigorous about it, right? Like, we could say that it's simpler to assume that because one yellow object follows some rules, all yellow objects follow the same rules, right? Or we could assume that how do I want to say this? Maybe this is a case where this is strictly simpler than the alternative. I was thinking that like, I can give some like really crazy overfitting examples, right? That like sound really stupid, but like technically are very simple, right? It could be that all yellow objects at this specific position give me my meter back, right? Or all objects of any color, like maybe that's too complex because I added two conditions. All objects, period, at this position gave me the color back, or gave me the time back. I guess you could say because there's a color match, that simplifies things. I'll have to think more about the argument I'm making here. I want to be rigorous about it. I do feel that it's true that you can't strictly quantify. So, okay, for example, like I think most people would say that like a linear function is simpler than a quadratic function with 1 degree of freedom. I think that's intuitively true. I would even say that probably a linear function with 2 degrees of freedom is simpler than a quintic function with 1 degree of freedom, right? Am I making sense? Let me open Notepad here. So we have two models. We have two parametric models. We can have y equals ax to the fifth, or we could have y equals mx plus b. Let's make them both m. Right. This one has more degrees of freedom, and they aren't one-to-one comparable to be able to say that one is strictly more simple or complex than the other. But I think most people would agree that this is the simpler one, right? This is kind of what I'm getting at when I say that there's a subjectivity when trying to make Occam's razor rigorous, but sort of an objectivity when it comes to what human nature actually is. And it's that we're trying to capture in a model in order to solve ARC-AGI. Okay, that was a very long-winded detour, but I think that was useful to clarify. We want to figure out what a good Occam's razor model really looks like, and that's why I want to iterate through all of these things that I'm saying. Anyway, we filled up our time back with the yellow thing. We're going to go here and rotate, and then we're going to rotate again, and it's a match. Now we're going to go all the way. I'm not going to bother counting the steps because I just assume it's going to work. Yes, it works. If I was in AI, I probably would have actually like looked at this whole path. Or if I was an idealized AI, I probably would have looked at this whole path and computed stuff. But I went off vibes there because it just seemed like the game was created to be solvable. Okay, there's a whole bunch of shit going on here. Wow. Okay, we have the player character and the end goal again. We have our symbol in the lower left, but now it's a different color. It's orange. That's interesting. Does that mean we have to switch both the color and the rotation in order to exit? We still have our yellow things, we still have our plus sign. We have these Is this a door? Is this a doorway? I'm gonna guess that's a doorway. And then we have this, which is a colorful thing. Because we are guessing that we have to change the color. All right, okay, we're starting with the hypothesis that we have to change the color of this thing in order to exit. Because the lower left changed colors, and that is a difference from the previous two situations, and it is different from here as well, which is interesting. We're going to assume that we have to change color to succeed, and because this is a multicolor thingamajiggy that we don't know what it does, we're going to assume that this thing changes the color. See, there's a lot of like common sense Visey stuff going on, right? But that is what I'm gonna work with. So what's our strategy then, assuming all of this is true? We need both the rotation from this plus sign and the color change from this. I don't know how many times we had to step through each. I forgot. If I was an AI, I would have actually paid attention to how it was rotating, but I didn't. So what's the shorter path? I can either go through here, recharge, or I can go up through all the way around through here, recharge, come here, recharge, come here. How many pixels do I have? At this point, I'm going to do some actual counting. 1, 2, 3, 4, 5. God, this is painful. I don't want to do actual counting, but if I was an AI, I would. Oh, but I can use length estimates, because we know that this guy is 5 blocks wide, so it's going to be 1/5 of this to move this distance. So this distance is about this distance. So, okay, we should be able to easily go through this door here and make it to this. So I'm going to go ahead and do that, okay? Up, up, up. Oh, wait, these are taking out 2 at a time? Shit. I think it's still probably okay. I'm going to do it. If I was an AI, I would actually calculate it. Oh, and that is not a door, which means I now have to update my model of the environment. I made the assumption this thing was a door based on my human intuition prior, and based on the behavior we just saw, we now know that's wrong. This is some kind of push pad thing. Okay, so that is a mechanic we've now learned. Okay, so from here I have to decide whether to recharge right away, recharge here, or go straight for the color. It depends on how much of this I have left. But I guess, like, if I'm coming back here and I only have one to choose from to deal with both of these, then okay, so I guess there's a few different paths here, right? If I come back here after, let's say I recharge, come back here, maybe I go here and then recharge again and then come back. So at this point I don't want to have to count. That's just really annoying to do. But I guess because I'm trying to simulate being a robot, that's what I will do. How many of these do I have left? 4, 5, 6, 7, 8, 9, 10, 11, 10 or 11 or something. Let's say 10. 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. I'm guessing I have to recharge sooner rather than later. So, okay, I'm gonna recharge here, go down here, come back up. Wait. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3. God, this is so hard to count. 2, 3, 4, 5, 6, 7, 8. Dude, I'm losing track trying to count it, but I think 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I think it's just 10. Dude, this matters though. This like really matters if it's just 10 or not. And hold on. Can I make it bigger? I can't even make it bigger. Come on. Come on. I'm so locked in right now. Okay, there's only 10, which means going down here and coming back for this is the wrong move, which means I have to recharge right away. If I recharge right away, okay, so which is better? Do I go to the plus, then recharge, then color, then here? Or do I go to color, then charge, then plus, then here? Will charge last me all the way to plus, then here? I'm guessing not. But see, these are all things that are like easy to compute. So like as the AI, what I would do as an idealized AI is generate the set of paths and compute the viability of each path, right? That's what I would do. Instead, what I'm gonna do is wing it, I guess. Oh, but this thing will push me. Great. All right, great. So we're good. I forgot about the thing that pushes you. And if I was a robot, maybe I wouldn't forget about that. But yeah, that thing is part of our model, so like I really just shouldn't have forgotten about it. Okay, so here, what are we gonna do? I also, before I do this, I want to speak very broadly about something I've just been thinking about, just a general model for how I want to approach ARC-AGI. ARC-3 3 modules for ARC. So fundamentally, I see ARC as being decomposable into roughly 3 modules. There is the vision system, there's the simulation system, which is modeling the environment itself, and in my opinion that's the most interesting system here. And then there is the strategy system, right? To put things into better words, the vision system processes the image into things like what are the components, what are the objects, what are their properties, which things. I mean, that's the main thing. What are the objects and what are their properties? And clustering them by the same object. Stuff like that is the vision system. The simulation system is you're in an environment with all these objects. What is your model for the environment? Like, can you write a piece of code that simulates the environment? Right, that's our simulation system. Then our strategy system is going to take our simulator and figure out the best way to actually plan paths to solve. I'm guessing the strategy part is actually going to be the easiest part. The vision is going to be... I don't know much about the current state for this kind of vision. I have to do research there. I think the simulation part is going to be the most interesting part, and that's why like I'm mostly talking through like how am I modeling the environment as I play the game, because that's the most interesting thing to me. The strategy part's also important, but the strategy is largely like, oh, this is how a wall works, this is how these objects work. Okay, we're going to define a bunch of paths, and then we're just going to like calculate across all the paths. And nothing so far has been like so incredibly high dimension that we can't do that, right? That might change. We're on level 4 of the first game, right? Okay, so back to this. So where are we? We're over here. Objectives over here. Now we have a different color and a different shape. Well, that is pretty interesting too. The order in which you learn information affects the assumptions you make, right? Because the first level only had a rotation, it was easy to see that there was a connection between these two things. If this was the first level, we would have to figure out manually how to change the shape and how to change the color, right? But because we have the 3 levels of experience so far, we know that this thing must change the color, and then our plus sign is gone. The plus sign is gone. We just have this thing that kind of looks like the plus sign, but it's different. So that's part of the vision system too, seeing that things kind of look the same or kind of different or like have shared properties or whatever. And we're going to make the assumption that this thing changes the shape. And these assumptions are... Well, let's see. If this was the very first level of the game, what assumptions would we make? For starters, I'm not even sure we would know what the player character is. I mean, this thing could be the player character, if we're being honest. And if these two things look different from each other, then it's like not even obvious that this is like an objective. I mean, maybe it is. Maybe it is. I do think that it is harder to model an environment that is more complex right off the bat. And the levels are intentionally designed... They're intentionally designed to allow a human to learn via curriculum, and therefore the AI should also be building up via curriculum, right? Anyway, we're going to go ahead and figure out how to actually play the game now that we know what we want to do. We want to get to these two things because we're making the assumption of how the model works. And there's all of these push pads everywhere. So this adds a lot of extra dimensions. I don't know. I couldn't ballpark how much in terms of like whether this is brute forceable or not. But let's see. Let's make the most obvious moves first, because we have to do that. We have to do that. Okay. We want to get to this. Last time one trigger turned orange into blue, so we're going to assume one trigger turns blue into green because that's how the shape looks. So that's part of the vision system. We're detecting. That's interesting. We have to like apply logic to these visual features. That's kind of weird. But we're going to assume that one time here is good enough. But how do we get there? That's the question. Presumably we'll have to pick up two of these yellow power-ups on the way to finishing the problem. So if we go down 2... Okay, this reminds me of Pokemon. Okay, so let's work backward from here. Okay, so that's like a new thing we're bringing into this. We're gonna do some backward reasoning instead of forward reasoning. From a perspective of like a brute force tree, it's not gonna be different. From a perspective of a non-brute forceable tree, it might be different. So let's work backward. We go here, and like we get pushed by this pad over here, right? Because the two spots adjacent both have pads. So we know that we can't try to like cut through either of these. We have to be pushed by this pad over here. Okay? So then how do we get to this square over here? One option is we get pushed down and then we come back up like this. That's one option. One option is we go all the way around. Actually, that's not an option, because as soon as we get here, we get pushed. So this is the only option to get to this color thing. Once we have the color thing, what do we want to do? Well, we're trying to get to the shape thing. We're probably running low on yellow at this point, so we're trying to get to the yellow thing as fast as possible. So probably go up, right, bump up here, down, down, get all the way to this yellow thing. I don't know if we'll actually have enough time for it. I hope we do. And then we'll go down, 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 down. Oh, wait, how do we get to this? So we have to take this push pad for pretty much the same logic as here. So we're gonna go down, 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 left, boom, shape shift. Then we're gonna go down, left, get pushed here, take this yellow, and then go all the way back up. Is that the most efficient path? I guess so. I don't see another option, so I'm gonna go with it, okay guys? That wasn't what I expected. Okay. So we're gonna update our model there in terms of like the order of the colors, I guess. I was just totally wrong about the visual feature thing. Oh god, do I have time to make it? Yeah, I have plenty of time. Great. Well, I just can't like estimate those things, I guess. Maybe we had enough time to directly go all the way. If we did, that would have been more efficient, and a proper path algorithm would have found that, I think. Yeah. Okay. It seems that working backward made that one significantly easier to solve than trying to work forward. Okay, so now we have another different shape, another different color, and we have a rotation and a shapeshifter. What that probably tells us is that we're going to have to shapeshift and then rotate. Fun. Which means we want to go... How do we want to do this? It means we had to come to this last, right? Because there's no way they want us to rotate and then shapeshift, because we don't know what shapeshift to expect, so that would be ridiculous for them to expect that from us. So we must have to go shapeshift, then rotate. Which implies that we probably want to go around this way, which means we probably want to get to the color shift first, which means up, left, up, up, up. By the same pushpad logic as before, we go up here. We take this up here, refresh, come here, boom. Take this, refresh, come here, boom. This seems fairly intuitive. Oh, wait, this plus moved around every time I moved. And if I was a robot doing this one step at a time, I would have noticed. Wait, is it moving? Wait, let me just reset it. Is it moving the same way I moved? So it's got a wall on top of it. So if I go up, it moved right. I went left, it moved right again. I moved up, it went left. I don't have a model for it so far other than to say that it's just going back and forth. That is my model of it right now. Let's see if that holds up. Oh, it went back to the right. So does it just go to those two squares back and forth? Yeah, I guess so. It's possible that some yellows I'm taking are not needed. And if I was a good path calculator, I wouldn't take them. But it's fine for this purpose, I think. Yeah, so it's just going to go back and forth and back and forth. And after, I'd say after one loop of that, one or two loops of that, that's enough to like know for sure that that's what it's doing. I also don't really see how it affects this. If I was like being super optimal with my yellows, then maybe it would matter in terms of the calculation. Oh, that's not even the right shape. Okay, is that the right shape? That is the right shape, and we have to recognize that's the right shape. Okay. Oh, I totally don't need to take the yellow yet. Why did this not push me? Oh, it was just laggy. Okay. Okay, so I go right, and then I go left, and then I go down, down, and then we just kind of win the game, right? Okay, wonderful. Yo, this one has 2 exits? Does that mean we need either exit or both exits? Yo, Vishnu, what's up, man? It could mean either, it could mean both. If it means both, we are going to have to use our yellows more sparingly. Also, we don't know if See, there's a few possibilities. Either we get a shape color match for this, and then a shape color match for this, and then go to both, or we get a shape color match for this and then go to this, and then come back, get a shape color match for this, and then go to this, right? That's harder. Do we just assume that it's the hardest case possible? I suppose if I was a robot, I would assume it's the hardest case possible and then see if the puzzle is solvable. And if it's not solvable, then I would change the hypothesis to a goal, to a different goal that seems likely, and then check if that goal is solvable. Presumably that's what I would do. It is probably not, it can't be either or. It can't be either or, because otherwise they wouldn't have the red just blocking the blue. It's got to be both of them, right? So let's work on the assumption we need the red, we need to hit the red, then we need to go back, shapeshift, hit the blue. Okay, so first we need to color and rotate only. That's convenient, color and rotate only. Probably hit this yellow. Come here, boom, boom. And then we're gonna go here. I mean, this shapeshifter thing would also be a red herring of those, yeah. So we're gonna go here, go up here, boom. Go down here, boom, and then probably take this yellow and go back. Oh, we may have to rotate as well, which means we probably take this yellow, go back. Some of that might be more optimal in terms of the yellows we take. It seems like so far, any suboptimalities are probably in terms of my yellow routing, I would guess. Because I think there's, most of the other aspects of the game have seemed fairly constrained. Oh, this thing also moves back and forth. Oh, it's getting away from me and they're all moving. All right. So now I have to find out all of their movement patterns. So the last time the movement pattern was purely left to right. Here, I'm going to reset this because I didn't pay attention. God, so much is moving at once. Okay, so this moved to the left, this moved to the left, this moved to the right. So far everything's only horizontally moving. So maybe it's the same thing. Move back and forth along the wall. That's the assumption I'm going to make based on the last level. That it's moving back and forth based on the wall. I don't know how reset works in the puzzle. I guess reset just counts as like one of your actions, right? And then if I go up, up. Okay, now we're good. And now, okay, so this thing is moving vertically. I should be paying attention, dude. So this is gonna move in a box. Why? Because I said so, and it feels right. That's not a great reason. Why is moving in a box simpler than it moving in an L shape? Why is that simpler? I think it is simpler. I think it's obvious that what's gonna happen is that it moves right next. I think that's obvious. But like, why? Is it just that we assume that is it because assuming a symmetry between these two walls is simpler? We like symmetry. Humans do like symmetry. Okay. Color. Okay, and now I have to be careful. Do I have time? I think I have time. Also, I'm not getting penalized if I lose, so... Okay. Do I have time to pick this up before? Probably not. I should just grab the yellow. That is a different shape than I've seen before. And that. And that. And that. Okay, finally. Cool. Do we do color first or plus first? Oh, I have chat blocked. Oops. My bad. Scroll to bottom. Oh, did you mean scroll to the bottom of chat? No, you didn't. Is this what you meant? This is where all the other games are. I'm gonna go through like a few of these games. I just want to finish the first game first. Oh, I can watch these replays. Oh, nice. Cool. Will do. Thank you. I will do that. After level 7. Man, this is just like some annoying like calculations, man. Like, so, boom, 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 boom. I don't even know like how many. So I know right now I'm like, it's gonna be moving away from me. And I guess I'm gonna have to come back for this yellow thing anyway. So sure, I'll go left and right. I'll go right and left, sure. That might have been a misplay. That may have been like suboptimal or something. And for our final test, we have Fog of War. I know this through intuition, as opposed to the fact that we are on a circular island in the abyss. We don't know where the exit is. Ooh, well, this is certainly more challenging. The only things we know, we have 2 yellows here, and we have a push pad over here. Presumably that's a push pad. We don't know the color or shape or rotation of the final thing that we want to find. Unfortunately, going either up or left doesn't really give us more information because we're at the upper left corner. So I'm going to go right because there's a push pad to the right, and that's interesting. And because I really don't think I have anything else to go on in terms of this. Okay, I found something. Something's yellow here. Presumably it's the same object as this. Presumably just another yellow thing. Correct, I'm right. And another yellow thing. Okay, and now we're in Padland. We still don't know where the exit is. We may lose a life in the process of trying to figure this out. Well, then again, there's so much yellow stuff around. They're being quite generous with it, you know. It seems that the fastest movement readily available to us is to take this push pad down right away. Otherwise, I could do down, down, here, left, and then that actually doesn't really help. That's not actually faster. So going left seems mostly slower than going right at this point. So I'm going to go right. Oh, and now we see that we have a red W-shaped thing. Okay, cool. We still don't have any of this. Oh, wait, is this the... This is the shape changer. So we found the shape changer, and we know we want that before the rotation, and we don't know where the color change yet. I'm going to pray the color change is up here. Oh, the rotation's up here. I could burn tokens going up here, investigating this token corner, getting this yellow coming back down. Instead, I'm just gonna like assume that the color thing is on the left. Should I take it? Yeah, I'll take it. Yes, I was right. I was rewarded for my hunch. See, technically that was a guess. I mean, you could say this was a simpler guess because we had more hidden information here than over here. Like, probabilistically, I was right. So, maybe we could say that was the logic involved there. Okay. Oh, fuck, I forgot what the red thing looked like. And if I was a robot, I would just, like, remember it. Oh, thank God, I can see it. Am I going to have to refresh? I guess so. Okay, that's accurate. Now we go all the way back. Oh, this thing's also been moving the whole time, apparently. I don't know the range of it. I'm gonna assume it goes all the way to the top and all the way to the bottom. Oh, I was wrong. Shoot, I screwed up. I did that a little suboptimally, I think, because of the plus thing at the end. I mean, I should have paid attention to the fact the plus was moving in the first place. I just wasn't paying attention for that. It seems that there's a lot of things that, like, I know what I would have done if I was, like, an idealized human. Okay, so now that we finished game 1, let's check out the replays. Let's check out Opus, which got 2%. I thought Opus only got, 2% on this game specifically? Okay. Is the human replay worth watching? Yo, slow the fuck down. What the fuck? Okay. Looking at this grid, I can see a complex level. I'm gonna take this base off. I was strumming it earlier, and yeah, it's getting heavy. Okay. All right. %. So, for those of you who don't know, the way scoring works is that each level is weighted by that level. Like, level 7 is worth 7 times as much as level 1, if I recall correctly. Is it squared? I don't think it's squared. I think it's just weighted. And then it's also weighted by how efficiently you solve the problem relative to humans. And I think they define an upper median human in some way. I don't know how. And there's a max score of being 15% faster than an upper median human, and that is how scoring works pretty much. Yeah, okay. Looking at this grid, I can see a complex level with various colored regions. There's a notable pattern around rows 31 to 33. Bro, I don't know. I'll take its word for it. Columns 20 to 22, forming what looks like a cursor or player marker. This appears to be a directional indicator, possibly a player cursor. It's not terrible that it's guessing that. Since I don't yet understand the mechanics of the 4 actions, I'll experiment to learn how the game responds. Has it not... What about the other stuff? Context to carry forward. Goal, complete levels. Okay, there's a player cursor marker. Okay, now it's committing to it. Key colored zones. 9 seconds? Bro, what does this mean? What is 0S and 1S? What is 9S? So it's calling these yellow targets, and it's calling these special tiles, and these 2 are special tiles, and this is just the bottom right, I guess. Gray floor. Okay, got background. Oh, this must be, it must have made like an ASCII map. That must be what this is. Because, no, it's not an ASCII map. The color, this is the index for the color, because we see the color. And it gets, I think, language about the color, but, like, it's getting numbers. So that's what this is. That's a little unintuitive. Okay. Did it figure out this orange-blue thing at all? It doesn't seem to have. Is this the special tile? Are these the special tiles? Bro, I don't know. I mean, this light... What are light areas? Are these the light areas? See, I don't know, because, like, I don't know what the number scheme is. I don't know what this really means. I'll start by testing action 1 to observe what changes. Likely a movement direction. I do think it's kind of BS that they give us left, up, right, down, and they don't give them left, right, up, down. That's pretty nonsense, I think. Unless it maps in like a really like clear-cut way every single game, which I don't think is the case. I mean, they're right about this being directional movement, but like, see, ideally they should just go left, right? That's what they should do. They should hit left. But no, instead they're testing action 1 because they don't really have a choice. Okay, action 2 is up. I don't like this. I don't like this. Claude is deciding to test more actions instead of doing the thing that gets him closer to the target. What did they say about comparing frames after action 1? I noticed a specific change at the bottom in the long 11 bar. Is that this thing, this yellow bar? The leftmost cell changing from 11 to 3. The player marker did not move. Bro, did you not notice this? I'm so confused. Is this dude just not noticing the actual player character? Bro. Really? Action 1 changed the leftmost cell of the 11 bar from 11 to 3. Okay, yeah, dude, this... It still thinks this is the player marker, it just doesn't know what this is. It just thinks this doesn't exist. Okay, and it's going to keep testing actions. And it just doesn't know what action 1 does after. Bro, wait, why is it this stupid? It shouldn't be this stupid. This is very weird that it just like completely didn't see this. That seems like a failure on the vision side, not really the reasoning side. The feature must have just like not been getting saved in an adequate way before it gets to the LLM. Because no way the LLM is gonna like miss this. The vision system must have missed this. Bro, I'm confused. Okay, let's test action 2 to see, and it went back down. Action 1 and action 2 produced the same type of change. Each consumed 1 more cell of this thing. Oh, dude, I didn't realize that they go down faster in future levels. I didn't realize that. Okay. After action 1, yeah, okay. Again, the cursor did not move. The 11 bar appears to be a move turn counter. Yes, that is correct. That's great. This gives me a limited budget, 40 moves remaining. Yes, that is accurate. Good job, Claude. Action 1 and action 2 did not affect the 0-1 marker or any other game elements so far. Bro, it did affect... Bro, are you joking? Yeah, the vision is fucked. Which means Fable might do, or Mythos might do better, because the Mythos vision is apparently a lot better. Wait, so why did Gemini suck so hard at this? Isn't Gemini's vision supposed to be pretty good? I guess Gemini's reasoning is bad. Okay, action 1. I don't know if that's actually true. I mean, I've had bad experiences with Gemini personally, but... Action 1 and action 2 had no visible effect. Yeah. He still thinks this thing's a player character because it... Yeah, I mean, I can't expect the reasoning to work if the vision's failing. Okay. Now I see a meaningful change. For some reason, the left made him see it and the up and down didn't. The 12 block moved left by 5 columns. This confirms the 11 bar. Okay, yeah. So now do you at least know that this block is the playable character? Action 3 moves 12 block to the left. It's the controllable object. Do you at least know that the other things are arrow keys too, or do you still think action 1 and action 2 do nothing? I mean, it's got bad intel from the very start. Like, I don't know why we should keep going. I mean, I'm curious, to be honest. Oh, read more. The 12 blocks sit just above a 9 block. Likely need to position the 12 block onto aligned with a target. The 9 block was its original position. Moving left may have been wrong. Does it not see that this part moved? It only sees that this part moved? Yeah, dude, the vision's just completely screwed on it. It's the vision is screwed much more than the LLM is, which is actually interesting from our perspective. in terms of what we should focus on. Even though I do think modeling the environment is like much more interesting. I mean, it's not doing a great job at modeling the environment, but that's, I mean, I'm surprised that it thought that this plus sign was the player character, because I thought the LLM would have the common sense stuff, and my common sense definitely said that this thing is the player character, for reasons that I can't put into words. I guess because it looks like a hairstyle. I don't really have words for it. Like, I just kind of could tell it's the player character. I don't know. Let me test action 4. Likely right or another axis. It is right indeed. Important correction. I misread before. Comparing carefully. Action 3, move the slider left, move it back right. Action 1 and 2, only tick the counter. No slider movement, likely up, down, blocked because the slider sits in a horizontal track. Bro, no, you just didn't see. Bro. Oh, what is it gonna do though? From here. Hypothesis: the ball, is that this thing? Is this a ball? Must drop into the lower chamber. The slider. It thinks that this is like an egg drop. It's gonna like drop this into this basket. That's what it's. It doesn't have the even remotest sense of common sense for this kind of task. I'm very interested in seeing what Mythos does, because Mythos is like trained a lot more on vision. But it definitely just like come on, man. There's no way you actually think this. It's clearly a top-down game. Oh, it doesn't know it's a top-down game because up and down didn't work. It thinks it's a side-to-side game because up and down didn't work. No, but it hypothesized the wall or the lane is what made up and... Bro, I don't know. It's conflating different paradigms. It's definitely interesting to see the way it's screwing up. But it's a little disappointing that it's so clearly on the vision side for most of it. Okay, let us play another game. All right. I will confess that I played like half a level of this. Okay, so what do we have? We have some headphones looking thing. I'm going to assume the black is floor and that the yellow and orange are walls, and that the blue... I mean, I'm going based on like what I assumed when I first played it. I assume the blue is... one of the blues is a player character, is what I'm going to assume. I'm going to assume that the goal is for me to get the blue on the left over to the blue on the right, and that I just like walk around. So that's my initial assumption. This was actually my initial assumption about this level. I go up. Whoa! Look at that. They both went up. So apparently I control both of them. Okay? I control both of them. I'm going to assume that if there's a wall in the way, it only affects one of them. Do lefts... are all arrows synced up? So how do we want to do this? We can... we want this to go up, and we want this to go right. So, and we don't want this to go left, right? So if I go up again, and then I'm going to go right, so that this first one doesn't move and this one moves to the right, and then go up with that. Oh, me going right made this go to the left. That's a boo-boo. So does that mean me going left makes this go to the right and that go to the left? Yes, it does. Okay. So now we go up, right. Oh, fuck. We go left, left. Then we go up, 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 right, up, right, up, right, up, right, and there we go. Okay, so now we have the same kind of thing. Wait, are the blocks a different size than they were before? Can I go back to the previous level? Yeah, these were 5x5s. They just shrank the block, and I'm just supposed to know that it's the same object, man. That's crazy. Okay, so first I guess I identify that the smaller object is in fact the same object. I make that guess. I have to play through this again. This one has a space and a mouse click to it, and I don't know what they do. Should I just find out? Okay, so far it seems like nothing. So far it seems like neither does anything. There's no object to interact with. Usually a spacebar does that. Are you one-shotting all of these? I don't know what you're asking. I mean, for the first game, I one-shotted all of them. For this one, I don't know if I'll succeed or not. Is that what you're asking? Okay, so now we're gonna zoom the two wall thing again. We have this checkered pattern. See, my assumption is that because it's red and black and looks different from the wall, it means danger. That's what I'm going to assume. And that means we need to navigate around the danger. Okay, so here I'm aligned with safety and this is not. If I try going down through this, this will get hit by the danger. So that's why I need to go up into this cove. Well, I guess maybe I could work backward. I say, how do I get these two things to be on the same line? And that means I need the horizontal movement on this to get stuffed. How do I get the horizontal movement on this to get stuffed? I put myself in this cove right here. And now I go left, left. Now we go down, 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 down. Okay. Now we go right, right. Oh, shit. At least clicking doesn't use actions. Do I click space? No, that wasn't it. How do I get them aligned? So if I go right, that's what happens. Oh, and if I go up, that's what happens. Ah. Ah ha ha. Okay, we have these small blue blocks. They're blue, they're not red, and probably most importantly, they're completely unavoidable. So I'm going to assume that that's not danger, and that we need to collect all three. I don't know what the significance of them are. I guess we just have to, like, get to one. What's the most efficient way to do this? So if I go right and then I go up, he's gonna get stuck here, and that's kind of annoying. I'm trying to get him to go up here and him to go up here, which means I need both of them to the right. How do I get both of them to move to the right? What? It means that I need to lock myself. So once this guy's over here, I can hit left over and over, and this will push him right. Alternatively, once this guy is over here, I can hit right over and over, and or I can hit left over and over, and this will push this right. Which is easier? Does it matter? I'm just gonna choose one, man. I guess because this has this extra cove, it's going to be more annoying, so... Okay. Okay, so now... I could go right to get the blue thing and see what it does. Yeah. Wait, it's blocked? Oh, do I interact? Space doesn't do it? Do I click them? What the fuck? Oh, and clicking uses... Okay, so... Clicking makes that the playable character? What the heck? And it uses actions at a lower rate. Okay. Oh, so that's why this was light blue, because it was selected. What the fuck? That's so strange, man. I sure hope I have enough time to solve this. Oh, shit. I'm gonna reset. I think I'm screwed on this one. Okay. So I guess I want to get them out of the way first. That's what I want to do. I want to get them out of the way first. It's tempting to put this here and this here, but then this guy is stuck. Ooh. How many coves do we have? We have this one, and this one. There's only 3. Well, I guess that makes our choices easy. There's a lot of counting and iterating through possibilities. I think it's really important for... Okay, this is one thing that to me is like implicit, but I should make explicit. I think it's really important for the vision system to return discrete components. I think this is super important. I think some vision systems already do this. I don't know what the state of the art here is, but this is really important. We don't just want like a bunch of deep layers of relus. Like that's not what we want. We want this is an object, this is an object, this is an object. We want sets of elements, and we want to reason over those sets. So in this case, okay, I'm gonna reset and like think about like how I. Okay, so what did I do first? First, I assumed that we had to pick up the blue things, that there were points in some sense. And I did a bunch of stuff to get over here, and I found out we were blocked. And at that point, I started using spacebar and click. Perhaps I should have used click earlier. And perhaps that's something I would learn for all the 55 private games. I should be clicking things more preemptively if they're new. Perhaps I should have clicked the red-black trap and see if anything happened. So from now on, I'm going to start clicking new objects. Once again, I'm blocking my chat. Okay. Yeah, so I failed to click. Once I clicked these things, so, okay, clicking made it clear that clicking over time uses these things and also makes these selectable objects. I guess... So my first assumption was also that the WASD remained on this, but I guess I should have noticed that this got deselected. If I was a true robot, I would have noticed that this got deselected. This didn't stay light blue anymore. This color changed. Because of that color change, it is the simpler option to assume that WASD now applies to this object. I think. Because we only expect, if these things look deselected and this thing looks selected, yeah. Okay, so then we reason that, well, we still want these two to come together, and there is only one path through which they can come together, which means these things have to be out of the way. Which means we have to put them in places that are out of the way. Oh, there's a fourth place that's out of the way. I missed that. So let's put them in places that are out of the way of the main path. And so, where do I put this blue one? I mean, I can put them in the same 3 spots I was going to. I guess this is a bit faster to do it this way. Yeah, I think that's probably... Okay, and now we're going to get our guys all the way up there. We still don't know what spacebar does. Okay, left, left, up, 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 right, 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 up, left, 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 up, right, right, down, down, down. Okay, cool. Great. We have now both the blue object and these orange things. Let me go ahead and select. Okay. Oh, even selecting unselectable things uses up actions. Shit. Well, that's good to know. This wall is yellow, which is the same color as this thing when it's selected. I don't know if there's any relevance to that. See, that's the type of thing where, like, the simple thing before was to say, oh, these things have a shared color, they must be similar in some way. But here I think they don't mean the same thing. And that's the simpler explanation, because that would involve the wall changing meaning in like a very substantial way that we don't know. Okay, so we need to get these things on the same page vertically. And right now, there are no vertical barriers of any kind except for the potential of this object. Which means to sync these things vertically, we have to put this thing, if I put it on top of this and move this down, that doesn't actually, oh, I had to put this down here, and then I have to move this down. And then I have to move both up. Seems reasonable? Okay. I didn't really analyze enough what I did there, I guess. Can we go back? I wish I could go back to a level more easily. That would be really nice. Essentially what I did was... How did I gauge that we had to vertically sync the two? Like, it was obvious to me that we had to vertically sync the two, but how did I gauge that? I guess logical deduction from first principles, that given that bridge in the middle, or it's not even about the bridge, right? It's not even about the bridge. It's just, if up moves both of them up and down moves both of them down and they're desynced to begin with, then the only way to sync them up is to block either the up or the down. So it just logically follows from first principles, I guess. Then from there, I said, okay, how do we achieve that? And I said that the only option for the vertical wall was going to be that block. And then from there, I asked, where do I put the block such that I can sync the two? And mostly got it from there. I think I might be skipping a step there that I'm leaving implicit. It's very hard to do this as like belaboringly as I want to. I guess like a lot of the labor happens in the first level, and then you're taking things for granted over and over. Okay, so here we have a bunch of shit. I don't know what's going on. We have many colors of walls, it looks like. That's confusing. Are they selectable? It would appear that none of the 4 colors of objects are selectable. But it also appears that if these things are walls, then there is no way to complete the level. It therefore follows that they aren't walls. Maybe there's something we can interact with spacebar. Maybe they're doors? Interesting that there are these like single blocks and then there's these like long horizontal blocks. Does that mean we have two different types of things? Are these switches and these doors? Is that, that's what I'm gonna guess. That these single blocks are switches and that these long blocks are doors, and that this single pink block is a wall like the rest of this. I'm going to assert that this is the simplest model of this environment. So why am I coming to this conclusion? I need to like very carefully walk through this. So first, what did I do? I noticed that there were many objects of different colors. First of all, I basically just assumed that every contiguous block of the same color pixel is an object. Then I said, oh, there's a whole bunch of these objects in different colors. Probably the ones of the same color have a connection. My initial assumption was that they were probably just like the same kind of object fundamentally, but then I noticed that for most colors that aren't the two walls, for every color that isn't the two walls or the selected thing, there are two sizes. There's a small one that's the same size as the player character and one long one. And from there, I used common sense intuition to say that the long one that is between doors, sorry, the long thing that is between walls every single time is probably a door, because if it was a wall, we wouldn't be able to complete the game, and it's between walls, so it's probably a door, and therefore the single blocks are probably keys or switches or something. Probably switches, because I don't know how a key would work with this kind of art style. Okay, that was a lot of fun. So now that we have the model of the environment, how are we going to strategize for it? We have to, I don't think we have a choice. We have a very clear thing laid out for us. We have to go to the purple switch first, then we have to go to the orange switch, then we have to go to the green switch, then we have to go and meet up here. I think it's very clear that that's the pattern. Well, alternatively, we open the purple switch, open the orange switch, and then open the green switch, and then come. I guess that's the same thing. And also, we don't know if the doors close afterward or not. So yeah, I'm going to plan to, let's start by just opening the purple switch. That'll confirm the theory, right? So we'll go right. Why is it backward in this one? Apparently, this one goes to the right this time. Okay, just to throw us off. Boom. I was correct in my model. Let's go. Okay, we're gonna go up, 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 right. Aha, yes, and I was also correct that getting off the switch closes the door. Boom. I go left, left, left. Oh shit, I didn't think about this aspect of things. How do I... I did not consider this aspect of things. I need to make sure I'm already aligned with the door this way before I leave this switch. Or before I go up, I guess. What am I saying? Yeah, before I leave the switch. I have to, Am I screwed from here? Do I reset? I don't think the first move changes. Okay, so if I go right, oh no, but I can't, okay. So I have to go through this door first. Okay, then if I go right, up, up, Okay, what do we do from here? we got the model. So I'm mostly satisfied at this point because I'm, again, mostly interested in the simulation system. How do we model this with Occam's razor as effectively as possible? And it seems like I got that part right. The strategy part I'm failing on, but I'm not concerned about the AI getting the strategy part right. I think for the strategy system, like, we can use heuristics, we can use things that Mu0 used. Like, I'm not really that concerned about the strategy part. We may have to be smart depending on how compute restricted we are, but anyway. I do just kind of want to finish this for pride reasons, though. Does it involve going all the way here? Do I go... How do I go right without this moving? The answer, okay, if I put it that way, this has to be over here. I have to get this over here. So boom, boom. Okay. Sometimes asking the right question makes the answer very obvious. I guess it's once again a form of working backward. But you gotta be smart about, like, when to know when to apply these statements. Hard. Okay, so now I'm gonna go right, 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 up, right. Let's fucking go. Okay, boom, boom. Now, if I go left, 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 left over and over again, he's gonna end up here. And that's bad. How do we stop that from happening? Oh, dude. Got him stuck in there. Let's go. So that was an update to my model. I guess my initial model didn't even consider the situation, because that's one thing I think we do with models. We by default, humans are selective about their domain. We don't just map a function from all reals to all reals in every situation, right? We take the patterns intrinsic to the input domain themselves and assume them in terms of as being the whole input domain by default, and then we add pieces as we learn more information. I think that's an important part of this. Okay, so now we have to ooh, that didn't quite work the way I hoped. How do we do this? I need to get this guy to not move horizontally and this guy to move horizontally. 1, 2, 3. Oh, I guess it's actually not complicated. Oh, it is complicated. Am I stupid? Wait. There we go. Oh my god, I keep screwing that up. Okay, I definitely could have done that faster, but I think we gained a lot of insight there about cognition. That was a good puzzle. This is the final level. What is Claude? How does Claude do on this? Claude got 3.71 on this? Claude did better on this than the first game? Well, I guess the first game just totally botched the vision, so... Alright. Okay, so we're starting up top, and because of level 5, we now know that we don't know which one is left and which one's right. Fun! Fun. So, we have 2 switches for the green one this time. We have 1 switch for the orange. We have a lot of danger. Hella danger. We still haven't used the space button for anything. We have this blue block to get out of the way. Okay. Removing all the movable objects. What's our path? This is the only path, right? We're gonna have to, like, get through here. We're aligned horizontally. That's good. We want to stay aligned horizontally. Looks like we're gonna get unaligned and then realigned, almost certainly. Okay, so one of the big questions is we're gonna have to get one of these guys out the door, which means we're gonna have to get one of these guys onto a switch and the other guy down, which means we need to vertically desync this, which means we need a barrier. The door itself can act as the barrier though. We don't have to move blue guy yet. And the blue guy can also go on this switch potentially, that's pretty cool. Which actually maybe it needs to, because that way this opens up, wait. Oh, here's what we do. We go down with this to wall or cell. No. We open the green switch. We go down here to wall of orange. No. I'm approaching this one the wrong way because we need to be going up this way. Wait. We want one to stay in place while the other moves in a direction. We want this to stay on the switch while this moves down. That means this needs to be blocked from the bottom on the switch itself. Okay, that's the composition I was missing there. I have some notion that the way that model building works is that we have some kind of dictionary of axiomatic components, and we grow this dictionary over time, and it's stored in some kind of like locality sensitive hash kind of shit. And so based on the context, we hash some shit that looks intuitive. This is like an intuition function basically. Stored in intuition hash table, let's say. It's not really hash, it's an LSH. And then from there we search this dictionary plus compose the axiomatic parts into like bigger parts. That's sort of my intuition for how humans do it. We like see, oh, I've seen this pattern, this problem. I know this kind of tool tends to work with this kind of pattern. And sometimes with enough experience, we'll say, oh, I know this exact combination of 3 tools in this exact way solves this kind of problem or this pattern. But sometimes we just have an intuition, oh, these tools seem like the right tools, but I don't quite know how it's going to work. Now I have to take all these tools, the ones that seem intuitive and right, and figure out how to work them together to actually get to the solution. So this is kind of how I think about it for humans. Okay. So I need to get solid below a switch. To get something solid below a switch, I need to go up, get on the green switch, take this guy all the way down here, move him down here. Now he's stuck on the orange switch. Move blue all the way down to the orange switch. Or move past the orange door. And then from there, I put the block on the left, move this all the way to the left to open the green door. And then I move this block to the bottom here, and then I move this all the way to the bottom. See, once I got that like composition of how to place the block, then I started intuitively being able to place it over and over based on the pattern. When I wasn't like getting that to click before. And that's kind of what I mean about you build this up over time, and until you have it built up, you like do search and compose. Okay, so now that I've said the entire thing, I think we can just do it. Oh, I couldn't step on that? Interesting. I guess because the green door is not there, it's opaque. That's pretty interesting. Oh, fuck. No! Motherfucker! Are you kidding me? Okay, If I was paying attention one turn at a time, I would have caught that. An AI would have caught that. Bruh. Are you joking? I swear to God. So I'm going to go right. No, I'm going to go... Oh, I have to put this on the other side. That's what I'm screwing up. Right. So now I have to go... I'm so confused. There we go. Jesus Christ. Oh shit. I have to leave this on. Oh shit. My bad. Okay, I could have done that faster too. Alright, let's watch Claude. Let's not go at light speed. Let's go one prompt at a time. Analysis of frame 0. Top row and bottom row are all 5. Yeah. Background split vertically. Various 5 colored regions. Okay, yeah. 2 distinct blocks of 10. Yeah, okay. So it's recognized the various regions. Hypotheses. This looks like a puzzle where 11, 12 are 2 territory regions. Yeah, that's kind of what I said. Okay. 5 are open path cells. That 5 is black. Okay. Yeah, that's correct. And 10 are interactive targets. Oh, 11, 12 are these walls. Okay, yeah, that's fine. Yeah, that's correct. And 10 blocks are interactive targets or the player marker, and that's correct. I thought 1 was each. Plan. Since I don't yet know the exact mechanics, I'll probe with a simple discrete action first to observe how the frame changes. Does something move? Does a counter change? This will tell me whether action 1 through 5 are movement, rotation, or selection. I'm keeping the 2 10 block locations in mind as likely targets for a later action 6 click. Yeah, this was good. It's for I'll already be thinking about this clicking. That's good. Context to carry over. Goal, complete levels. Yeah, sure. Key features, the 2, yeah. Okay, so we're gonna start by just testing action 1. I really hate that they don't get the arrow keys. That's so stupid that they don't get the arrow keys, dude. Like, come on. What are you talking about? You don't get the name of the button. Like, humans get the name of the button. We didn't get action 1, action 2. It's not 1-to-1. BS, man. Alright, anyway. What is reasoning coordinate overlay? What does that mean? Does that mean it's going to show things here based on... Okay, let's find out what happens. Okay, it was up. Action 1 produced no visible change to the grid. Once again, we just have an immediate vision problem that is going to break the entire system. Yeah. However, reset is now available, confirming the game register in action. Okay, yeah. So it's going to try clicking these things, and I guess it's going to find out nothing, because they're already selected. Oh, this is going to show me the clicks, I guess. It clicked the... Bro, are you seeing this? Look at this. This is so revealing. It just clicked the original location and just like totally doesn't see that it moved. Look at that. Like, there's no point even evaluating the rest of the vision. Or the rest of the reasoning if the vision is this broken. Okay, let's play it on... Oops. Let's play it on forward and see what happens. Okay, it finally, through enough moving around, figured out that it can do stuff. So I guess maybe we should go back and take a look at the reasoning there. I mean, it solved it. Let's see how it does here. Okay, see, it was stupid right off the bat. It could have been smart. It actually made it to level 3. I'm shocked it made it to level... I'm not that shocked. It took it a long time to make it to level 3. Okay. I'm gonna go through this and then probably have to go after that because it is Chiper's dinner time. You wanna say hi to the camera, Chipey? Yeah? Come here. Oh, you just want to lie down. Okay. Good boy. Okay. I guess I don't need to do that. Level 1 complete with an emoji to celebrate. So typical. The convergent corridor strategy worked. Now level 2. New layout, new colors. 8 new elements. Spikes, targets. Okay. There's a central wall with put a warning emoji next to that. Appears solid. The 2 chambers may not connect. So meet in middle likely won't... Bro, it doesn't go all the way through. Are you joking? Goal main should be each avatar reaches a target in its own chamber or avoid the 8 tiles. So it just like... Once again, because of a vision issue, it just went completely off board. Yes, I'm coming, baby. Give me 1 second. Give me 1 second. And does it... What does it think about the spikes? At least it thinks it should avoid the spikes, so why doesn't it? Why doesn't it? Let's go forward a bit. Okay, so from here, what's going on? Left align with verify the gap is open all the way, context to carry forward. Did it just fail to plan the descent correctly? I'm gonna guess it's a vision issue, I don't know. Anyway, I unfortunately must terminate at this time. I'm gonna stream more of these games later. I think I want to see like the different kinds of logic involved and talk through more of the stuff. I think this is a useful discussion to have and useful prompting to give Claude later on. Cool. All right, thank you guys for tuning in. Hit that subscribe button, and I'll catch you later.